his morning routine, Trevor runs for an hour at 15 kilometer per hour, then he warms down for 30 minutes at 10 kilometer per hour. What is the total distance he travels in his morning routine? At what time is he halfway there? So, first thing that we want to find is the distance traveled, the total distance traveled. And we have the two timelines, and we have two different speeds. So basically, let's remind ourselves of the formula for that relates the velocity. If it's constant velocity, is going to be x divided by t. So the distance traveled divided by time it took. So over here, each piece, see, 15 kilometer per hour is a constant function. And then over here, 10 kilometer per hour is a constant function. So each piece separately follows this formula. In Calculus 1, we expand this formula to more than this, basically. Now, what I need to do is, here I'm looking for distance, so I have to So to find distance, I have to multiply the velocity by time. So the distance 1 is going to be velocity times time, and the time he travels, the first is 1 hour, and 15 is the velocity. 15 times 1 equal to 15. Then distance 2, while he's running at the lower speed, again is v times t, and that is 10 times, this is half an hour, times 0.5, and that is 5. Add them together, and you get 20 is total distance. I want you to notice this. Here, the total distance is, that's the y value is the velocity, and the x value is the time. So this rectangle gives you the first distance 1, and this rectangle, this area of this rectangle, gives you the second one, gives you distance 2. So the total distance traveled is the area under the graph of the function from the beginning to end, basically. Now, the second question, let's write this down, that's 20. And the second question is asking, he travels exactly, it's asking at what time is he halfway there. He travels exactly half that distance at whatever a.m. So to find the half distance, basically, let's say, what is half the total distance? Total distance is 20, so half distance is equal to 10. Now, it just seems like from now it's nice to look at the area under the graph. I can tell that the half distance happens somewhere around here, because if it happens over here, it's not, the area is not halved. So area is halved somewhere around here. And that makes my life a little easier. Just using the graph, I can tell that I can use this formula when I have the distance, I don't have the time, and I have the velocity. So velocity in that formula is 15, the distance is 10, and then I find time, and t is going to be basically 10 over 10 kilometers divided by 15 kilometers per hour. That's in terms of hours. Now, if I want to make it in terms of minutes, I have to multiply by 60. And the answer to that is going to be, there's actually 15 in 60, and then I multiply that by 10 to get 40 minutes. So I got the 40 minutes. Now let's see. We started at 7:30. And we want to add 40 minutes. And we end up with 8:10. So the answer to this is 8:10 a.m.